Hi, it's Robin. Since I had the Commodore 128D out again while doing an interview with Citizen's Clicky, check the video description for a link if you want to watch that, I thought I'd make a video about 10 interesting Commodore 128 BASIC features. This was a suggestion from viewer Brian B. I'll just be in 40-column mode today, but I hope to be able to do video capture 80-column mode soon, thanks to a solution from my patron Karsten Lervad, which should open up some other topics I've wanted to cover for a while. Okay, now to look at the Commodore 128 BASIC, called BASIC version 7, which answers many of the complaints about BASIC on the Commodore 64 and eliminates the need to use so many of those pokes to use the Commodore 128's features. By the way, there were two major revisions of the Commodore 128 ROMs. This is the second version, copyright 1986. There is a version, copyright 1985, that was mainly included in the flat original Commodore 128, but it has quite a few bugs in it. I made a video about quite a few of those differences. Look for a link in the description for that if you're interested. This was also the first time that Commodore acknowledged that Microsoft had made the BASIC for the Commodore computers, going all the way back to the PET in 1977. The first thing we'll look at is the improved screen editor on the Commodore 128. Now, back in 1977, when the original Commodore PET was released, the included full-screen editor was amazing, and in fact, that same editor in the Commodore 64 in 1982 was still pretty good compared to most of its competition. But by 1985, there was definitely room for improvement. So you may have found on the C64, say you're typing something and you want to insert, and you hold down the Shift Insert key. That's a little bit weird. Plus it has the weird side effects of this quote mode and everything. By the way, Shift Return to get out of that. So instead of this Insert key, you can put the editor in an insert mode quite easily by pressing Escape and A, and then any typing you do, hello, will just automatically be inserted. And it's Escape C to exit that and go into regular type over mode. That just replaces whatever's under the cursor. Another neat one is Escape I will insert a blank row. And so we can do that. And you can also Escape D to erase the rows or even erase a whole line, like so. If you don't like that the cursor blinks, Escape E will disable the flashing and just make a solid block cursor. That's really weird for me to get used to. And Escape F will make it flash again. Also, if you want to erase everything before the cursor, that's Escape P. And you can erase everything after the cursor to the end of the line with Escape Q. And if you want to wipe out everything from the cursor, the whole bottom of the screen, Escape and the @ symbol will do that. You can also scroll the whole screen down with Escape W. And you can scroll it back up with Escape V. And there's even more. I actually made a full video about this quite a while ago. And again, there'll be a link in the video description. I also made up a cheat sheet PDF that gives all the escape codes in one convenient place that can be downloaded from the video description of that video, called Join the Commodore 128 Escape Club. So you might notice I'm actually grouping a whole bunch of features together. The Commodore 128 has so many additions to the BASIC, so we're not just looking at 10 commands, but 10 groups of either commands or features. Number 2, Sprites. This is a pretty crazy command. If you type in SPRDEF, Sprite definition, and hit return, it actually goes into this full sprite editor. And you can give it a sprite number, they are 1 based for whatever reason instead of 0 based. And here we can edit a sprite. It shows you what's currently in memory, which is just like garbage. So we'll hit clear, and then you can just move the cursor around and press 2 to draw. What terrible art am I going to make today? And 1T race. There's a little guy. We'll give him a hat. There, it looks just like me. And you can see that up in the top right corner, it actually shows the sprite as it appears. If you press X and Y, you can expand them in the X and Y axes. And when you're done, press Shift Return. You could edit another sprite here if you want, but we'll just exit by pressing Return again. And you see that you can go right back into the sprite definition, press 1, and there's our guy. That to me is a pretty amazing feature that's built right into the ROM, and that eliminates the need of all those long data statements that you might remember from the Commodore 64, 63 bytes, 63 numbers to define a single sprite. And if you want to show the sprite instead of all those pokes on the C64, you can just do this, sprite number 1. We want to enable it, so it's another 1. And then the color of the sprite, we'll do color 2, which is white. Again, on Commodore 128 BASIC, they made most of it 1 based instead of 0 based. So normally we're used to black being color 0 and white being color 1, but you add 1 to everything in C128 BASIC. Well, most of the time. And 1 for the priority, whether the sprite appears in front of or behind characters. So let's press return, and there he is. Actually, if we put an extra 00 at the end, that'll shrink him down to regular, unexpanded size, and 1 and 1 will expand him. Okay, so that displays the sprite, or enables the sprite, and now if we want to move the sprite, sprite number 1, we'll put him at position X100 and Y100. And there he is, on top of our characters. Let's move him down the screen a little bit more. You can also, instead of doing absolute placement, you can move him from his current position with plus in front of the parameters. So that does a relative move of 20 pixels right and 20 pixels down. There he goes. And negatives work as well. Move him back 20 pixels. And if you even want to move them smoothly, sprite number 1, and then the angle you want them to move at, 0 is straight up, and 90 degrees is to the right, and then the number or hash sign and the speed you want them to move at. And there he goes. And you could do odd angles as well, like, 71. There he goes. And you can change the speed. 9 is even faster. And 2 is slower. Just wraps around when you hit the borders. And you also notice that the movement is under interrupt control. The Commodore 128 is doing that movement in the background, so we can just continue to type and use BASIC. Okay, we'll leave him running. I'm not sure if how long we can keep him on screen for, but we'll move on. Number 3 is music. Again, on the C64, it required lots of pokes to get any sound out of it. On the C128, there is a play command, and you can just type in the names of the notes you want, like C, E, G. And here we go. And it just plays those notes, C, E, G. You can make it do harmony as well by telling it to play in voice 1, C, voice 2, E, and voice 3, G. And instead of playing the notes one by one, it'll actually play them simultaneously by using the 3 voices. So it's just a short chord, but so there's a little C major triad for you. And the play command can actually handle very complicated strings. So we can tell it in voice 1, octave 4, envelope 0, which is supposedly a piano sound, volume 5, X0, that's no filter, that's filter off, and then the notes, C, D, E, F, G, A, B. Let's hope that works. Okay, so that's playing 7 notes from C up to B. So I'll link to the C128 Programmer's Reference Guide. Page 55 has a full list of all the parameters that are available. There's a lot. And you can change the speed with the tempo command. Let's try that. Quite a bit slower. Okay. Or we could change the tempo to 100, way faster. Let's hear it. Okay, so that's like nearly a sound effect there. You use that, it sounds kind of like Jumpman jumping. Quite a while ago, I made a video about how to abuse the play command to actually play back digital samples. Pretty nasty hack. So again, I'll quit saying this over and over again. Check the video description for a link to that video called C128 Basic Hack Playing Digital Samples. All right, example 4 is the high-res graphics commands. Again, this took lots of pokes and was actually really slow on the C64, doing it poke by poke to deal with high-res graphics, which are 8,000 bytes of graphics data. So instead, if we do this graphic 2, okay, I'm going to turn that sprite off. Sprite 1 and 0 should disable it. Yeah, there he goes. So I think I was showing this in a recent video, but when you go graphic 2, it does a split screen. So this bottom area, the bottom 5 lines are text, and up above it, the cursor's disappeared. That's actually because it's a high-res bitmap that the cursor doesn't appear in. It's not obvious right now, but it will be in a moment. So you can just do the draw command, and you tell it to draw in the foreground color. That's 1. 150, for example, I'll just plot a dot at X100 and Y50. See that tiny dot up there? You can just add a 2 and give it another pair of coordinates like 200, 70. And now it's drawn a line. And you can actually string multiple 2s. So back to say 2, 150, 90. You can actually draw triangles or whatever you want with that. And there's other commands like circle. Again, the foreground color of 1 at coordinates 180, and then the width and height. So it's a circle command, but because you can put a variable width and height, you can draw ellipses as well. And so here, this one will be wider and not as tall. Of course, the C128 doesn't actually have square pixel ratio, especially on NTSC. So that's why they look kind of stretched. So the commands work as if the pixels are square, even though they are not. And you can clear the screen clear, and just a couple more commands. Again, there are so many commands in here. I'm just giving you a very brief overview of many of them. So you can draw a box from the top left corner at 50-50 and the bottom right corner at 100-100. And you can actually make neat patterns, like if you do a little for next loop for x equals 0 to 360, step 12, And then we'll do that box from just the same one, 50 to 100. And then we'll add the (x) parameter. That's actually the angle that the box is going to be drawn at. And next. And let's see how that looks. What? Oh, whoops. I forgot the draw color. Okay. It's kind of annoying if you get an error, it kicks you out of the graphics mode. So go back into graphic 2. We'll cursor down here. Okay, I'm going to use that escape W to push my code back down to the screen. How about that? It was still on the screen, but it was in this top high-res section. The text is still there. It's just hidden under the high-res graphics. Okay, let's try this again. Ooh, like a spirograph. Okay, we can do another one here. Step 15, I don't know, step 20 maybe. And we'll go here from x 150. I'm just adding 100 to the x coordinates. 200. And here we'll do that. Okay, so that's kind of fun. And there's even escape at. Clears the bottom of the screen. Ooh, that's nice. Maybe I should make more videos in C128 mode. And there's even this paint command, paint, and you give it, again, foreground color, and then the coordinates, he'll do a flood fill. It should fill the left-hand pattern. There we go. And graphic 0 will exit you back to text mode. And there's our missing text. Okay, the next neat thing is something called Windows. Now, not Microsoft Windows, but just these text-based windows, which you may find handy. So let's just do a little classic 10 print. Just to fill up the screen. Okay, so now we can do this window command and define the window from X and Y position 5, 5 to the bottom right corner of, say, 20, 15, and comma 1 means to clear the window. Okay, so watch what happens. So what it's done is create a text window here on the screen, and it says ready. So if we clear the screen, you see it only clears what's inside this window. Clear. And when we cursor around, it wraps around here. And if we even list our little program we wrote, it appears inside that window. And the screen even scrolls, like if we're to go down to the bottom here, list. And I believe it obeys the commands, like if I do that escape and at symbol, it should clear everything from the cursor down, again, just within that window. And it might not be obvious how to get out of a window, but you just press home twice or print home twice. Home, home, and now you see the cursor's up in the top left corner, and we are free from our window and can clear the whole screen now. Another common complaint about C64 BASIC was how the code is so spaghetti, it's not very structured. C128 BASIC doesn't hugely improve on that, but it does give you a couple nice things to make your code a little bit cleaner. So if I just do a different version of that 10 print program and just compare the random value that returns a value from 0 to 1, if it's less than 0.5, then we're going to print the shift N and a semicolon, and then I'll put a colon, and now here's the long-awaited else command, and we can actually go around to the next line if that helps with the formatting. Else, print, and shift M, and a semicolon. And then line 20 can be go to 10. So if we run that program, it prints the classic maze. And if we list that, so it's great having an else command because C64 just didn't have one at all. And sometimes you had to do pretty terrible workarounds with go-tos, and it just got messy. There were some workarounds, but it's just nice having the else command. The major limitation is that the else does have to be on the same line, the same logical line number here on line 10 as the original if. You can't put the else on another line with a different line number. It just gets ignored. But on the bright side, if we want to get rid of that line 20, we can actually insert multiple commands before the else and then after the else, and they will get executed. So if we go into that insert mode, escape A, I could put an extra colon, and then I could do a go to 10 here, and then after the else, colon, it can have its own go to 10. This is kind of a terrible example, but just to show it works. Okay, so it's working as expected. If we list it, we can see here that it's printing this slash and then going to 10. Else, it's printing the other diagonal and it goes to 10. And one other big thing that helps with this, again, it's a bit ugly, but C128 Basic has extended the logical line length from 80 characters, that's 2 physical lines on the Commodore 64. On the C128, it actually allows you to have 4 physical lines or 160 characters per logical line. So that also helps you pack lots of instructions in with your else when you need to. Again, kind of ugly, but it works and it's better than nothing. Another more structured programming technique is that C128 Basic has a do and loop command. So again, this is just like a trivial example, but it shows you what's going on. If we just increment X and print it, and then we can loop while X is less than 5, for example. And it just prints the numbers 1 through 5. But this do loop construction and be able to use while can be a lot more clear and flexible. In C64 Basic, you only had 4 next loops or if then go to were your only ways of doing loops. So this is more flexible. And you have not only while, but you can also do until X is greater than 4, for example. And run that with the same effect. And strangely, you can do both while and until on both. Like we could change this to do while and loop until X is less than 10. And run that. Okay, and you see the do while immediately is false, and the commands inside the do loop aren't even executed a single time. So that's also handy. Just seems strange. I don't know if I've ever seen another language that lets you do while, do until, and loop while and loop until, both at the top and the bottom. What happens if we do that? Run. Oh, we only get one iteration here, because the do while is true, but then the loop until is not. So this is a muddled mess, right? What am I going to get here? 1, 2, 3, 4. So it seems the exit condition can get flagged at either end and holds true even if the other condition at the bottom would allow another loop. Okay, interesting. All right, so that was less spaghetti. Okay, so I'll keep that program in memory. Okay, so I edited line 40 just to make it just the loop. And moving on to number 7. So on the C64, there were no means to renumber or do auto line numbering or any of those kind of conveniences. Often people would get an add-on cartridge or add-on software to provide that. Commodore 128 Basic includes it. So you can go auto 5. And then, for example, if we add a line 50, just do a remark here, you'll see it automatically gives you the next line number, rem, nothing. So just increments by 5s. Okay, so if you've inserted lots of lines, and eventually your program's getting really sloppy, you can just type renumber, and then now it's cleaned up your code by renumbering everything going by tens. And you can even have it start as a certain line number, like renumber 100, and then it'll do by tens starting at line 100. Or how about renumber starting at line 111 by 11. There. So, whatever. Okay, I'll just renumber that again to clean it up. Okay, and now on to number 8, debugging commands. So what is our program doing right now? I think it'll print... Oh, no, it's broken. Okay, so I'm just going to fix this program up. 20x equals x plus 1. Get rid of 50 and 60. Renumber. And run. Okay, so we've got our little program that just prints the numbers 1, 2, 3, 4. Again, just a short little example. So Commodore 128 adds some debugging commands. How about Tron? Now that is an awesome name. And now that we've turned Tron on, that is trace on, we'll run the program. And what it does is it prints the line number currently being executed in these square brackets, and then prints the output. So you see this program, it just does exactly what it says here, executes line 10, 20, begins to execute line 30, and then actually prints out the value of x, and then line 40 jumps back to 20. Interesting that line 10 isn't really executed again. I guess it must implement it using the stack or something, so that's kind of interesting. It seemed to me that in a way, part of line 10 is executed, but, well, who am I to argue with Tron? I don't know how useful that really would be, but again, it's there, and it might be helpful if some people see the program flow printed out like that. It'd probably be especially useful if you dump that out to a printer, and then you could follow along on your paper output. Okay, and to disable that, of course, it's troff. Tron, or trace off. Okay, now we could add an extra line, this trap command, trap 1000. And what that does is if an error occurs, it's going to jump to line 1000 to handle the error, to trap the error. And line 1000, well, it can be whatever you like, but for example, we can print out from this error string array, pass it the error number. These are system variables that are reserved or defined. So error string is just an array of error strings, and you pass it the error number you want printed, and then the error line number. And line 1010 can be resume, which resumes execution after that error has occurred. Okay, so let's list the program. So it should run like normal. Oh. I wasn't expecting that. Pretty sure error was 0. Oh, 14. Illegal quantity. Interesting. Okay, so line 50, end. I should have ended the program because this trap routine shouldn't be called normally. Let's run. 1, 2, 3, 4. Yeah, that's probably a little bit too quick. So I'm going to have it print there, the numbers 1 through 20. And you see nothing happened. But here, if I run and press the stop key while it's still executing, see what it did? It printed break in line 30. So this is kind of interesting. When you try to stop your program by pressing the stop key, C128 Basic considers even that an error, and you can trap that and respond to it. So you can actually block the stop key if you don't want the user to be able to stop your program because it's just treated like another error. Or another thing we could do is add a line 45 and just put some error. Okay, so this is obviously a problem with the program. And actually, we'll just shorten it back up to 5. We don't need so many. repetitions this time. Okay, so let's just run it. And you see it's syntax 45. So it's just saying that line 45 has a syntax error. And of course, you don't have to do this resume. You could just end the program if you find it annoying how it keeps running despite the error. Let's try that. Run. And there you go, syntax 45. So you can imagine all sorts of ways of using that trap to trap errors. Again, I actually did a full video about Tron and trap called Debugging C128 Basic with Tron, Trap, and more. Moving on, number 9. Well, it is a basic command called monitor. And it gets you into the built-in machine language monitor that the Commodore 64 was sadly lacking. Now, I actually just earlier this year did a very detailed video looking at the monitor built into the Commodore Plus 4 computer. That was a very long video, and obviously this one, I'm not going to go off onto this whole tangent about the monitor, but having this built in is excellent. If you want to look at a detailed breakdown, that Plus 4 monitor is extremely similar to the one built into the C128. But the one detail about the C128 I want to look at is here, the program counter. If you're familiar with machine language on the Commodore 64, you're used to a 16-bit program counter. Each of these digits is a nibble, 4 bits. So 4 digits is a 16-bit address. And the C128 adds a 5th digit here on the left, which you might think means that we have a 20-bit program counter, but we really do not. In C128 speak, this is called the bank number, bank F, and you might think that means that we have 16 banks of 64K, but again, we do not. So the M command in all these monitors displays memory. So if we monitor F4420, over on the right side, you'll see something familiar if you've watched some of my other videos. These are the basic keywords in the basic ROM: data, input, go to, go sub, return, and so on. So what we're looking at is the basic ROM, but it's not really at this 20-bit address. This first nibble, it's called the bank, but really it should be called memory configuration F. So what this nibble does really is tells the C128 memory management unit to configure the 64K of address space in a particular way, which includes the basic ROM from location 4000 all the way up to BFFF. So that's what we're looking at here, at address 4420 and on. And up in high memory, the kernel ROM is there. So if we look at memory at E4420, you see it's exactly the same thing. And that's not because there are 2 copies of the kernel ROM in C128 address space. It just means that memory configuration E and F have the basic ROM in common. But if we look at bank F D000, this is actually the VIC registers. But if we look at E D000, instead we see these values, which are actually the character graphics data built into the ROM. The font built into the Commodore 128 is available here. So you can see 2 banks might both have the basic ROMs available, but then it'll be IO in one in F and character ROM in bank E. And some banks won't have basic at all. For example, if we look at bank 0, location 4000, that's actually some of our basic code from that last program we were working on. I believe this is the trap, line 1000 right here. And bank 1, at 4000 is just basically uninitialized RAM. So bank 0 looks at the first 64K of RAM, where your basic code is stored. Bank 1 looks at the second 64K of RAM, which is where your variables, arrays, and so on would be stored. So Commodore 128 memory management's a very confusing subject, and not one I'm an expert on, but I hope that gives you some clarity about what that bank number is for. Rather than thinking of it as a bank of 64K, it's a configuration that tells the C128 how to view its 64K, what elements to switch in or out. C128 processor can only see 64K at a time, but between all the RAM and ROM it has, it can only see about a third of all the resources it has at any given moment. And X to exit out of the monitor. And finally, number 10, disk commands. The Commodore 64 got a lot of flack for its cryptic disk commands like load $8. And this is just a disk I happen to have lying around. So 128 mode addresses that. There's a directory command, which can be shortened to DI-Shift-R. Or even better, there is a C-Shift-A, which is short for catalog. So if we just have a little program like print test, you can save that with dsave, which is just ever so slightly easier than save, 8. And there's our program test. And if you've ever tried to rename a file on the C64, it's a great big command, open 15, 8, 15, all this. Instead, we can do rename test to whatever. We'll make it into the best game. And now if we do a directory, you can see that file has been renamed. We can load it with dload best game. Oh, just to be clear, I'll do a new first. Now I'll deload it. And we'll list it. And there it is back in memory. And we can even scratch it. That means delete the file. Best game. Are you sure? Yes. And again, that avoids one of those awkward open 15, 8, 15, quote, S colon, best game, close quote, colon, close 15. Okay, so you can see the file is now gone. One other related one is this bsave, block save, or binary save, you might want to think of it as. And you could save, for example, the sprites in memory from P3584 to P4096. I don't even know what that P stands for, but that's the syntax. The programmer's reference guide doesn't say, or at least I couldn't find, why it says P. There it is, the sprites file. And then that can just be loaded quite simply with sprites, or with the bload command sprites. So that's really nice to have that kind of load and especially save feature built in to do a block save of memory for things like graphics. And if you're curious earlier when we drew that sprite how you would save it, well, that's how. Okay, and finally, the Commodore 64 is often criticized for not having an auto boot feature, while most other disk-based computers could auto boot. So that was fixed. Ultima 5 in particular, just going to put that in here, is a Commodore 128 enhanced game. If you play Ultima 5 on a Commodore 64, it doesn't have any music, as they ran out of RAM apparently. But the Commodore 128 version has the music, thanks to the extra RAM, and the programmers acknowledging that. So I'm just going to reset the computer, but you'll see, booting, the Commodore 128 has an auto boot feature when you start it, it checks the disk, and if it's set up as a self-booting disk, it will just automatically load and run, which is really nice. Actually, here's just a little interesting Easter egg. I've restarted the computer with the disk out. Of course, it couldn't boot with that. I'm going to put the disk back in, and you can just type the boot command to boot a disk without restarting the computer. Now just look what it prints on the screen here. This little Easter egg. Boot. Searching for XYZZY. Longtime computer nerds will recognize that. So that's a little funny little reference that the Ultima 5 programmers put in. Nice callback. Okay, so there's that Ultima 5 with the music because it's running on the C128. Okay, so that's 10 big improvements Commodore 128 BASIC made over C64 BASIC. Lots of good stuff, but I should mention that it does have a cost. Of all the 8-bit Commodore BASICs, it's the slowest executing. And the main reason is because of all that bank switching going on. The Commodore 128 still has a 16-bit address space, 64K, but with the 128K of RAM, 16K kernel, 32K basic ROM, and all the juggling around that is needed to simultaneously have the basic interpreter in memory, and then your code and variables all in different banks, in different areas of RAM, all that juggling around causes most of that slowdown. But it's not all bad. For a lot of purposes, all the extra functionality of Commodore 128 BASIC more than makes up for the loss of pure speed. So be clear, like the graphics commands are fast, the sound commands are fast, compared to doing a bunch of pokes on the C64. But if you were just to have like a tight loop doing some simple math, you'd actually find that the Commodore 128 is significantly slower than the C64, VIC-20, PET, and so on. Of course, 2 MHz mode makes up for that in some ways, but that's only available with the 80-column screen, but it has its own slowdowns related to moving graphics through the relatively slow 80-column video chip. Really, that's a topic for another time. Okay, so thanks very much to Brian B. for the question. Thanks so much to my patrons for their patience while I've been sick for a while. And thank you for sticking around and for watching. We'll talk to you next time.
Hey, stop right there. What's that supposed to mean? Can't you say anything else? Well, what else? Positive or negative? 0 or 1? True or false? On or off? You're a bit where's your program? another mouth to feed. You're a bit, and I'm your program. Bit, help me out here. Should we go left or right? Oh, should we go left?